Guys, after the sample program which we have discussed earlier, now we'll move towards uh, next part, which is the data types, the reserved words. We'll learn further about the data types and what their meaning is, because as we have discussed earlier that first part is our declaration. Okay, means we have to first know about the data types which we are going to declare first. Okay, so let's start the reserved word and their meaning. Reserved word and their meaning. So our first reserved word is integer. Our first reserved word is integer. You have to write int only, not the full part integer. It is known as integer. And what is the meaning? It accepts the integer value and returns the integer value. That means it only returns the integer value and is an integer. You may think that this is going to accept the integer values. Our next keyword is void. Void. From the name itself, we can know that the work of the void is nothing. So, what the technically the meaning is? The meaning is that indicates the main function receives no data from the OS. Indicates the main function receives no data from the operating system. That means it is known that the program is going to receive nothing. That's why it is void. So our next reserved word is double. It indicates that the memory cells store real numbers. Okay, the double, let me write that. Double. This will accept the floating point numbers, or you may say that the numbers with decimal notation. Okay, this will accept the decimal notation. What its meaning is that indicates that the memory cell store real numbers. Okay, indicates that the memory cell stores the real number. So our last reserved word is return. Okay, this is not a data type. It is the return means what that particular function is going to return. If you are sending any argument to the function, then what it is going to return, the meaning is only that. And technical, returns control from the main function to the operating system. Okay, returns control from the main function to the operating system. Okay, so I hope you have understood better about this. We'll again go further in depth with integer, double, floating point, character. More data types are also there. We'll focus more on that. So our next part will be user defined identifiers and what are the rules to define the user defined identifiers. So let's move to our next part. Now we'll move to our next part, user defined identifiers. What is the work of this? The user defined identifiers are nothing but we choose our own identifiers to name memory cells. Okay, we choose our own identifiers to name the memory cells that will hold the data and program results and to name operations that we define. We have also studied earlier about the standard identifier. Okay, it's nothing, the name that is being related to the memory cells only. So here we will see what is user identifiers and the rule. So first let me write the user, what is the user defined identifiers. So it is nothing but we choose our own, that it is nothing but we choose our own identifiers to name memory cells that will hold the data and program results. Okay, so we choose our own identifiers to name memory cells that will hold the data and program results and to name operations that we define. Okay, so you now knew about the user defined identifiers. So now our next part will be what are the rules to declare these identifiers, the syntactical rules. Okay, so syntax for declaring a valid identifier. Okay, so our first rule is an identifier must consist only of letters, digits and underscores. Okay, let me write the first rule so that I'll show you and will explain you. An identifier must consist of letters, digits and underscores. An identifier must consist of letters, digits and underscores. Okay, so let's have an example. Identifier must consist of letters, you can say A, B, okay, digits and let's say digits. Okay, you can write like that, like this. Okay, so we'll understand what the second rule says. An identifier cannot begin with a digit. Okay, an identifier cannot begin with the digits. Okay, we can also consider this only. I have not started with the digits, just of letters. Okay, so what our third rule says? Our third rule says that a C reserved word cannot be used as an identifier. Okay, a C user word cannot be used as an identifier. I'll make you understand what this line is. C used, sorry, C not user, a C used word. Okay, C used word, or you can say reserved word. A C reserved word cannot be used as an identifier. Okay, this line says that there are some of the keywords which are being already defined in the C program, like swap, sqrt, pow. Okay, these are the some of the C reserved word. Okay, which are already being defined in the C program. To so when you will declare those type of keyword, if you are in need of declaring those keyword, just at the end write a digit 1 or 2 or 3, something like that, so that the name will not match. Okay, so what our fourth rule says? Our fourth rule says that an identifier defined in a C standard library should not be redefined. Okay, so an identifier defined in a C standard library. Standard library means those the library functions. Okay, should not be redefined. Otherwise, error may occur. Okay, so let me write that. An identifier defined in a C standard library. Identifier defined in a C standard library should not be redefined. Should not be redefined. Okay, otherwise the value from the library will override your declared value. Okay, because we are declaring in the first line, we are using preprocessor directive and the directive to access the library function and bring that library function into the C program. Okay, so automatically that value will override your defined value. So it's better to not use the identifier of C standard library. So in the next part, I will show you that some of the identifiers which are violating these rules. Okay, so that you will get some idea on that. Okay, so let's move to our next part. As I have told you, I'll show some of the examples which are violating the rules of those identifiers which we have discussed earlier. So let's have a look on invalid identifiers and reason for being invalid. Okay, well also I'll also tell you that which rule it is violating. Okay, so our first one is one letter. So which rule it is violating? Rule number one, that an identifier cannot, must not start with a digit. So, okay, so must not start with a digit. Okay, our second one is, okay, so okay, here is the rules. Let me define rules. And our next part is 2 star 4. It is starting with an alphabet. It is correct, but the main reason is that star. The star is not allowed because an identifier must consist of letters, digits, and underscores. So it is not included in those. So you can say that it belongs to rule number one only. Letter say Joes. So what is wrong here? Same. This is not allowed. Is not allowed. Don't worry. Now we are moving to a quick exercise. Now we are moving to a quick exercise where we'll solve some of the problems on identifiers. See reserved word. Either it is a constant macro or not. We'll know briefly on that. So guys, let's move to our next part. Guys, here is the quick exercise which I have made for you. If you want to solve it alone, you can pause this video and can have a look on this. Which of the following are C reserved words, standard identifiers, conventionally used as constant macro name, other valid identifiers, and invalid identifiers? So let's solve this problem. So what is the solution of the first one? Void. It is a C reserved words. So A, option A. You can check it by going back, by moving backward. You can see I taught you on the C reserved words and some of the syntax of invalid identifiers also. Return is also a C reserved words. Third one. This is a long one. Okay, it can be a conventionally used as constant macro name or other valid identifiers, because valid identifier may consist of must consist of letter, digits, and underscore. So the answer may be C or other valid identifiers. Okay, fourth one, max entries. This is only conventionally used as macro name, because macro names are only, you can redefine it, but macro names are only defined in capital letters. Wherever you will see this type of any name with underscore, blindly select this option used as constant macro name. Okay, fifth part is printf, which is a standard identifiers. Sorry, write the option standard identifier, which we have discussed on that sample program which I taught you. So sixth one is double, which is again a C reserved word. Seventh one, XYZ123, other valid identifiers. It is satisfying that rule. 8. Time. It is other valid identifiers. Then comes the last one, part has to. Guess what is this? Obviously, it is an invalid identifier because it consists of a special character has only underscore is allowed. Blindly select that option, invalid identifier. So guys, in the next part we'll move further in depth with fundamentals of C. So let's start with the next part. Guys, next, after the quick exercise, we are going to discuss what is a variable. You'll be familiar with this. A variable, a name associated with a memory cell whose value can change. Okay, a name associated with a memory cell. A name associated with a memory cell whose value can change. The variable, a name associated with the memory cell whose value can change. As we have already discussed in the programming part, what is a variable? A data type with a name. The name is called the variable, which points to the memory cell whose value can change. So what we are going to discuss next. Next point is variable declaration. What is a variable declaration? Statements that communicate to the compiler the names of variables in the program and the kind of information stored in each variable. Okay, I'll again explain you. Variable declaration. I'll explain you and write. Statements that communicate to the compiler the names of variables. Okay, statements that communicate to the compiler. A variable declaration is statements that communicate to the compiler the names of variables in the program. Variables in the program. Statements that communicate to the compiler the names of variable in the program and the kind of information stored in each variable and the kind of information stored in each variable. Okay, from the statement itself, let's focus on what the statement says. Statements that communicate to the compiler. Okay, this is a statement which communicate with the compiler the names of variable in the program. Okay, what are the names of variables that are defined in the program and the kind of information stored in each variable, either it is a double type or integer type. That signifies that the kind of information stored in each variable. So variable declaration communicate with the compiler that these are these variables with these kind of values stored in it. The work of this is this only. So guys, the next point we are going to discuss is data type. What is data type? A set of values and operations that can be performed on those values. Okay, data type is nothing but a set of values and operations. Set of values and operations. A set of values and operations that can be performed on those values. Okay, this data type is data type means data type. It belongs to the declaration part, the data type and the variable. So what this data type defines? This data type defines that the variable must store the kind of values which this data type accept. Okay, a set of values and operations that can be performed on those values. So next, on the next point, I will describe you on valid double constants. Okay, what are the valid double constants and integer constants, character and ASCII values? So let's move on to our next part. Guys, we have discussed on the data types. Now we'll see some of the examples with valid double constants and invalid double constants. That will make you clear on the double constants, okay? Because further we are going to face questions on this only. So valid double constants and invalid double constants. Okay, so first one. The first example is 3.14159. It is a valid because this is of double type. Before decimal this is number, and after decimal also numbers are present without any comma, dot. Okay. Similarly, on the other side, the example is 150. Okay, no decimal point. It is invalid because 150 is an integer type value, not a double type value. That's why it is invalid double constant here. Now the example is, let's say, 0.005. It is also a valid one because with decimal point it is present, and the other side 1 2 3 4 5 e. It is invalid. Why? Because the value for the exponent is missing. No exponent value. Okay. So our third point is 345.0. This is also valid. If I will remove this part, this two part, point and zero, it will get invalid. The other side, 15 e minus point minus 0.3. Okay, I forgot the Is it? That's why, sorry. So 15e minus 0.3, it is also invalid. Guess why? Because 0.3 is invalid exponent. Okay, 0.3 is invalid exponent. It must be a real number like 3, 1, 2. We'll later on see on that. So our fourth point is 15.0 e minus 0.4. This is value. What the value is? It is just like 15.0 into 10 to the power minus 4. So what is the value? 1, 2, 3, 4. 234.0. This is the value. It will skip. Okay, let's see here. The point is here. It is minus 4. It will go backward. 1, 2, again 0, 0. If there is no value, satisfy it with the zeros. 0, 0. Then it must be a double one. So 0 point. That's all. Okay. Let's say here another example, 2.34 e2. So it is also like this. So what it is gonna do, it is plus 2. So it will shift right one 2 2.230.0. Okay, 2, sorry, 2.34, right? Sorry, 2.34. So 234.0. Okay, then let's have an invalid identifier. Let's say 1.2 e point 3. It is also invalid. Point 3 is invalid exponent. That's all. Then solve again one more problem. 0.15 e minus 3. What will be the value? If you want to calculate, then pause it and calculate. I'm going to calculate here. It is 1.15 into 10 to the power minus 3. As this is negative, it will go backward. 1, 2, 3. 00115.0. Before the point was here. Now it will shift 3 points backward. 1, 2, 3, and the point is here. To make it satisfy, put a 0 here, and that's all. Here, another uh, problem, 34,500.99. You might be thinking that this is a valid double value. Okay, no, it's not, because your value must not contain comma. Comma is invalid. Okay, you have to write the number, because we, the humans, are using comma to make the reader make easy, but the compiler will not accept comma, so that's why it is invalid. So in next topic we'll see how how the memory, how what is the memory type of the integer and what is the memory type of double, because integer contains only one memory, that is block, that is one memory block, that is binary number, and double format is three consists of three blocks: sine and exponent and mantissa. We'll discuss. Okay, so let's have a look on those problems too.